Now we all hopefully know how to count with regular integers. We just take 1, then 2, then 3, and so on to 50, 1,000, a million, to infinity. But what is infinity? How big is it? Does it even make sense to think of infinity as a number? The truth is, infinity is less of a number and more of a concept, a useful tool for mathematicians to think about and compare unending sets of numbers. What do we mean by comparing unending sets of numbers? Well, as it turns out, some infinities are bigger than others. Before we can understand this, we need to have a stronger idea about what size means. It may be a good idea at this point to visit our video on sets if you don't have a good understanding of what a set is or how we define cardinality. Two sets A and B are said to have the same cardinality if each element of set A can be assigned to an element of B and vice versa. So if we have 5 apples and 5 blueberries, these two sets can be said to have the same size as we can assign each apple to a blueberry such that there are no apples or blueberries that have been unassigned. The set of 5 blueberries and 6 carrots are not the same size, as if we assign each blueberry to a carrot, there will be 1 carrot unassigned. Therefore, the two sets are different sizes. With this information, we can now consider infinite sets. Consider the set of all natural numbers, that is, every integer, 1, 2, 3, etc. This set is said to be countably infinite, as when we are counting it, we always know what the next number in the sequence shall be. That is, 2 will follow 1, 5 will follow 4, and so on. We assign the cardinality of a countably infinite set as Aleph null. With this information, we can now look at some interesting applications. We know that two sets have the same size if we can assign each element from one set to a unique element of the other set, such that no elements from either set are unassigned. Now look at the set of all even numbers. Surely there would only be half the number of integers as the set of natural numbers. However, if we merely shift all the numbers over by 1, we can now see that we can assign each even number to a unique element of the set of natural numbers. So the set of even numbers is countably infinite and has a cardinality of Aleph null. Now what about other types of infinities? Let's look at the set of all real numbers. That is the set of all regular numbers such as -3.4, a half, pi. How do we begin counting this set? If we start at 0 and want to move up, what is the next number? We can go from 0 to 1, but what about 0 to 0.5 or 0.25? We can go from 0 to 1 over 10, but what about 1 over 1,000? In fact, for any number we choose to be the next number in the sequence, we can just think of a smaller number. So there is no way to count the set. Therefore, it is uncountably infinite.